So this is the pulse width modulated analog out example. Again using the Grove buzzer, passive buzzer, gives a slightly nicer sound. So go to Grove in Scratchpad, go to analog output, piano. I had fun doing this, as you can tell. So this one, if you go like that, analog out, column 11, this will tell us that something's connected. This is a link to the device. If we run it, hopefully you'll hear the delicious and you can play with the duty cycle, and that's the off button. So let's again do that in slow-mo just so you can see how it works. I won't do this in slow-mo, but the pulse width actually doesn't use the ANAC, it uses the GPIO. So here, if it's A0, it will be 26, 27 for A1, 28 for A2. So let's do that. And then it will come through here. If it hits if you get a mouse down event on the button, the button will then do the frequency. So I googled all the frequencies of the piano keys. The duty cycle will deal with kind of loudness. I've got it set now to a nice-ish value. And you can see here I've gone through every one. Now you could optimize this. You could take, like I've done with all the mouse ups, you could put it all in one event, and then depending on the control reference and name, you would set the frequencies. But I thought it's just kind of easier to understand if I do it in this way. So let's run it, and then we go slow-mo so we can see what's going on. And I press A4. And then I release it, it sets it to 0 again. B4. It goes back to 0 again. Okay, and that, so I've done a funky stop button as well because I thought it looked a bit more like the stop button on an organ. So I did that. Oh well, off it stopped. So yeah, you've got lots and lots of controls, so you don't always have to use the. So this is, I think, a classic stop button. Let's have a look. Yes, one of those. So you can find all sorts of good things to make block diagrams look a bit more realistic. Yeah, and that's the analog output and pulse width modulation. The pulse width modulation I'll probably explain better in the documentation, but essentially it's a square wave where the duty cycle of the square wave is how much goes. It's just based on the frequency of that. That's a really bad explanation. So when you press a button, it sets the frequency. So the frequency of the square wave. The duty cycle is the amount of power, and it's the percentage of the square wave that's positive, shall we say. Probably best done with drawings, but I'm not going to do that.